Welcome to part 10. It's a round number for the first sprint. Last time we got a little bit stuck on, I don't recall what we got stuck on, but we got stuck on something. So we didn't quite manage to print last time, but this time it should definitely work out. Oh, welcome Raj, welcome Pasimir. Um, yeah, I think we can more or less pick up right where we left last stream. I did do something small in between. And hi, Mr. DSI. I did something small, and that is I changed the bearings on the x-axis. Oh yeah, and this one I broke. I also tell something about that. On the x-axis, I changed the bearing. So on y, it's still like rocks like crazy, but on x, it doesn't. Like I can't like twist it anymore in this direction. Um, So I think that the bearings I have are not good. So kind of like the story here. Can I center it somehow? Okay. Well, the story here is basically that I forgot the username, but somebody showed up on the Discord and asked some questions regarding a Prusa Mini, which this is kind of meant to be a Prusa Mini conversion. And it kind of led down like a little bit like not a rabbit hole, but like a journey. And then I kind of like realized this is a Prusa Mini conversion, so it uses the Prusa Mini parts. This is why these and these have LMU8 UU bearings, which means these parts come directly from Prusa Mini. And on the Prusa Mini, the same bearings are used. So on the Y in the Prusa Mini, it's a bit different because like you have like the bed moves back and forth, right? It's the bed slinger. So you have two bearings here and one bearing on this side. So this has three bearings, which kind of also prevents this motion. So for this one, it was clear for me that would work. But on the tool head, the Prusa Mini has the exact same setup. It has two vertical like 8mm rods like this, and then it uses two LMU 88 bearings. So on the Prusa Mini, this can't wobble as much because like the print quality is horrific. So on the Prusa Mini works. So something had to be off with the parts I had. And we compared my rods. The rods are 8.1 to 8.2 millimeters, which is the same as the Prusa parts. Somebody's on my door. That's bad luck for that person. But basically that means my bearings had to be off. So I ordered new bearings and I ordered new like roller bearings, I guess. But what I still had were these bushings. So just to show you the difference, this is the part we had, or we used so far. These are like standard bearings. These are Fuji branded ones I got from AliExpress. But I think these have like way too high tolerance. Like they're like too wobbly on the rod. These are bushings. So here you have like these like, I'm sure it's a bit hard to see on camera, but you have these like rows of balls in here. Here you see like one of these rows, and there are like four of these rows of balls, and like basically the bearing is riding on those balls. On these, you don't have any moving parts, so these are just basically gliding. The plastic here is self-lubricating. These are actually the original Dryden by Argos. But the plastic is a little bit self-lubricating, and they have a very tight fit, but they still like glide over the rod. They have a bit more friction than the roller bearings for me. Okay, 1 second. Someone is really insisting on me opening door. 1 second. Sorry for that. DHL was very insistent that I sign this parcel. And where we? Yeah. So basically, I have a bit more friction for me, but it works quite well. On the poor man's cork spy, I had a lot of problems with these. I think the frame wasn't stiff enough, and like the frame twisted a bit, and the roller bearings, they are better at tolerating very slight, like if the bars are not, or the rods are not super parallel, the roller bearings kind of tolerate that. But for the bushings, like it immediately like locks up. So I think that was partially the weak frame construction of the printer. Let's see. So I tested this a little bit here on the x-axis. We made it move last stream, so I kind of used that. And it works. So let's see. I didn't do the Y yet because the Y are quite iffy to swap out. The X are actually quite okay to change the bearings. But yeah, I will wait for the new roller bearings I ordered, and I will try the roller bearings first. Because if the roller bearings have also less play, I think I would prefer the roller bearings, just because they have a lot less friction. So that's kind of like my train of thought there. But good news, like I think we can get this fixed. Like this is good. It's just like the back and forth rocking now, but left, right, it's completely gone with the new bearings. Okay, then the second thing I noticed, I actually broke it off now fully. This is the air duct here on this side. My lead screws are a little bit too tall, so I think I have to cut off like 2-3 centimeters of the lead screws. Because I mean it's kind of like bad luck. On this side, it just clears by a hair. This seemingly like I cut like a little bit longer and like it just touched. So I broke off the duct basically when hoeing wide. But yeah, that's not too bad. We can replace this part hopefully relatively easy, but I think we have to take apart the tool head. Let's see. Um, Nevertheless, let's continue configuring because that's kind of like where we were. So let me actually quickly open that thing up. So what we can do, we can completely home that thing. And what I did now, I used, oh yeah, I also installed already the TNC Auto Tune plugin for Clipper because these endo motors have horrific vibrations. It's absolutely insane. And TNC Auto Tune plugin like removes that immediately. So it can move. I feel like oh yeah, I changed the acceleration here to 10,000. And it can move quite quick. So that works quite well. But yeah, that's kind of like the limit is like roughly, I changed that to like 500 millimeters per second. Yeah, 500 millimeter per second. And acceleration is 10K. And then the steppers kind of like die out, like the skip steps. But it's, of course, we don't use a lot of amperage yet. But yeah, like these values are good enough. Like my concern was just like because there's a bit more friction, that this would completely kill off the performance. Doesn't seem to be the case. So I think for me, these dryland bushings would be a possible solution. Hey Steve, welcome to the stream and thanks for your donation. I will directly convert it into bearings. Okay. Oh, and hi there, Marmon Tattoo. Welcome to the stream. Cool. Yeah, so where were we? We configured the steppers, that's all configured, but I think we did not even yet configure the toolhead board MCU. So that's, I would say, the next step. Looking at this, I think we also have to move the probe a little bit up. But yeah, that's all connected to the MCU on the toolhead. So let's see where we get there. I think if we refresh the CAN here, like we should just get, yeah, exactly. It should just give us the CAN UUID. But let's just start with the EBB36 config. And I still have the old one. There's the V2 by now. But I have the 1.3 or what it is. 1.1, 1.2. Sample. Okay, let's just copy it over step by step. So we take that. Yeah, now I have two things copied. I just call the thing EVB36. Yeah, this we now have copied. But this is now serial. We want the canvas UUID. So serial would be if you connect via USB, but we don't connect it via USB, we connect it via canvas. And the UUID basically identifies every device in the canvas network. Okay, so that's step one. Then I think I will just copy out all the things. We don't need these. We will need to configure the probe in a second. I'll just append it to the bottom. And I will quickly replace EBB CAN, which is the name they use, with EBB36. This is how I call that board. I like my name better. And that should have configured the extruder, the accelerometer, or at least the ADXL. And I'm not quite sure what type of thermistor we are using here. Because we had a couple of iterations on the hot end. I think it's a fetus conch. Oh, but we use the same, we reuse the heating element, if I recall correctly. Now, how was that called? There was a TZ 2.0 hot end thermis. Whoops. So basically, we wanted to use this TZ hot end, but the mount didn't work. So we then I bought the fetus conch, but we reused the heating and the heating element and the thermistor. So I think I recall that at some point on the bottom here it says the thermistor type. You reuse the heater and thermistor, yeah, from TZ2 exactly. But I remember I used the wrong thermistor before. There was like some footnote here somewhere. I think. I don't see it anymore. The steel's all not interesting for us. Didn't say anything regarding the heater. Otherwise, you just leave the standard for now and see what it does. But I remember last time we configured it, I should have saved the configuration of the poor man's. I did not, which true amateur mistake. I see. Does it say here? It's the same image with the information. I like that these are always images. No, it's exactly the same. There's a bit more information here, but also not what we need. Okay, let's just leave the standard thermistor 3950 or something. Yeah. Yeah, with the 104 and T, I had burn plastic, exactly. So this is kind of what we have to adjust. But TZ 2.0 Clipper config. There must be something online. I mean, this person has a generic 3950. I think this is also what we ended up using. Yeah, I still use the generic 3950. And just see what it does. The problem is always like you cannot really check it. Like the only reference you have is whatever the clipper tells you the temperature is. Um, I also want to remove the space behind that stuff. I don't like the space. I just replace the spaces. Oops. Keep me here. So, but I think this should be all to just very quickly see if we can heat the nozzle. Oh, a lot of chat messages. I started building my Satsuma with a Bowden extruder designed by designing my own tool head. When I saw the price of the bamboo clone hot end, I decided to make the original tool head, but gave up again. Seeing the Hawaiian Orator. I don't know the Hawaiian Orator. Do you know how, which Orator models fit the tool besides the 2.0? Can I use a Sherpa mini set? Um, I am not 100% sure. You need to check the mounting pattern of these extruders. I know that they're almost the same, but they're a little bit different. I mean, what you could do, I don't recall exactly what shape this part had on top, but you can technically in Fusion just fill the holes that are made for the screws and like put two new holes in. So you can just like modify this part. I think that's what I would do if I would have a different extruder. Might not look as pretty because like you didn't adjust then the front shape, but it would be at least technically working. But I would check what extruders have the Orbiter mounting pattern. There might be, I think the Pocket Watch has the same mounting pattern, but don't quote me on that. Might also be the Sherpa mounting pattern. So yeah, that's need to see. But if you are building the same machine, do you have issues with wiggling of the Y and X axis? Like for me, this is like very, you see it here on the screws, like I can wiggle this back and forth. I think it's my bearings. I'm pretty sure at this point that's my bearings are not good. But do you have the same issue, or is it like for you it's solid? I have the same problem with TZV6 config. I solved using 3950. Yeah, I think we also used the 3950 last time. And hi there, Harlem. Welcome to the stream. Okay, so we restart that. It didn't give any errors, which is a good sign. So let's just very carefully see if stuff is working. So we also didn't configure the bed yet, I think. Now that I think about it, but let's see. So do I have temperature? Yeah, I have temperature controls. So usually what I do is like to just heat it to 30. And that works. So temperature, oh, you don't see it again, but the temperature rises immediately to 30. And a very loud fan kicks in. Okay. We, like right now, the part cooling fan kicked in instead of the hot end fan. So we have to quickly switch to two. Heater fan, so this is PA1 and fan. Oh, we didn't configure the part cooling fan yet. Okay, then let's quickly check the EBB36 pin out. I should like print this as a poster because I use this like specific pinout so often. PA0 is that on. So we have PA1 at the moment configured. PA0 is what we need most likely. So I will just swap it over to PA0. PA0 is used multiple times. So we did configure PA0. Oh, okay. Never mind me. Sometimes I don't see the forest for the trees. Let's see. So this should turn on the park cooling fan, which it does. So that means if I now put this back to 30, I expect a small fan on the side too, which is the case. I wonder if this is enough airflow, but I assume it is. Okay. Hi, Dom. Welcome. So then we said we didn't configure the heater bed yet. Give me some example configuration, please. Let's just pop that here. Oh, we should say Pusha mini clipper config because that will give us config. Steve, ever complained about my config being complex? It's like quadrillion files. Print Pusha mini. So I'm just looking for the bed so that I have the correct sensor type here. This is literally all I need here. Which is exactly what I had configured already. Nice. Let's see if we can heat something. Wait, I should maybe adjust the pin. Let me see. I also never saw this control watermark. We should quickly check that. Then we need the SKR Pico pin out. And I'm not 1000% sure which one we plugged this in. The one next to power. So we did plug it into the hot HB hotbed thing here. So that's IO29. You can always find something to complain about. That's good. Oh, I forgot also something else. Complaining is good. It improves stuff. Heater pin. I assume I use GPIO26. No other random pins? Yes, I could use a sample configuration for this board, but that would be too easy. Heater bed, temperature 175, not in range. Well, that means one of two things. It's either that we didn't use the correct pin. So it's plugged into the last one, to yeah, GPIO26. So I think it's plugged in. which is curious because I think everything's plugged in. Now quickly remove these covers here. Oh, this one I actually leave on. That shields a little bit the AC wiring stuff. That's not the worst idea to have on. So I mean, this looks good to me. That's the correct pin. I have the camera setting messed up again. Ah. Question is if the wire is broken. It shouldn't be. It just goes in here. Or it's just the wrong sensor. Man, I wish we would have saved, by we I mean me, saved the config of the poor man. Um, hmm, that doesn't exist. That's weird. Didn't you swap sensor pin, heater pin? I don't think I swapped sensor pin and heater pin. GPIO 26 is the sensor. Oh, fuck. Yeah, I did. Ah, my brain is already in weekend mode. Thank you. Magic, it works. Thank you. Also here, let's quickly heat to 30. And we should see the temperature rise. We do not see the temperature rise. So something's still off. No, it doesn't rise. Let's check and so I use this port, which is oh my god, it's IO21. I'm not having a good track record today with my pins. Yes, we're using CAN bus. That's a CAN bus connection. I basically use the same hardware as on the poor man's works fine. Like I want to one copy this over. Yeah, now it's rising. Yep. Yep. I see like a red LED on the bat. It is rising. It's just a tiny bit slow, but here we go. Now it's rising. Okay. So that's good. So we have the heaters working. I would like to work a little bit on the homing. We also have to do the screw tilt adjust. No, it's not screw. Back tilt adjust. So let's check for flipper configuration reference. Let's quickly first do the input check because we already have the ADXL configured. So I'll just throw it in here. That's not what I wanted though. Resonance test is what I wanted. Resonance test is what I wanted. So basically you have to configure the ADXL, which is the sensor, and then the resonance tester. So all we need to do here is the probe points. And we will probe at 1990 10, so it's like center of the bed. Then we need the Axle chip, which is our ADXL. These I would all leave at their defaults, so we can kill it. And I think probe points. Not sure if you need dash here or not. Let me see. Nope, no dash. Okay, perfect. I have nothing to do tonight. Mr. Desire is catching all your mistakes. Yeah, he is learning from the best and catching mistakes. So then we wanted to do the prop. So let me see. I mean, maybe it's easier pin the probe. I don't think there's anything special to the probe. Let me quickly see how we wired that thing up. It's a 3-pin probe, so I think the blue one is the signal. So it's plugged into the end stop here. Yep. So we have on PB6 is the probe pin. Then let's just hop here, because it's a relatively straightforward probe, right? Like it's not like a clicky probe or anything where you need to configure a lot. So we don't have activate, deactivate checkpoints. We leave everything on default. Z offset is something we need to configure. I would just set it to 1 for now. X, Y offset. So that's now something we need to check. Like it doesn't need to be like perfectly precise, but it's definitely centered. And where do I have my calipers here? And I'm just quickly measuring the distance between the nozzle and the center of the probe, which is like 20 millimeters. So we have an X offset of 0 and a Y offset of, now is it plus or minus 20? I think it's minus 20 because it's in front. And the pin we set is EVB 36 PB6. So that should be our probe. But I think we definitely do have to put it up a little bit. Like looking at this, it's very close over the bed. Like, let me see. Oops. It doesn't like PV6. So basically, if you look here, the nozzle and the probe are basically the same height. So I will just quickly move that a little bit up. Let's see. We have to completely remove the screen cover here. How does it work? Like it's not. No, okay. Well, it was a bit too much. Although I think this Pinder probe has quite a long I wonder why this doesn't come off. Like something holds it still. The screws are loose. Wait, it's also clicked in here on the side. I think that's what holds it in right now. Okay, now I can move the probe up and down. That also works. We need to check the trigger distance though. Let me quickly check if I can. Let's first fix this issue here. So PV6 is not valid. Do I have to capitalize that? PV6. PV6. Okay, now we can query the end stops and the probe is open. So now I'll just manually move the bed up. And I think they trigger quite a bit out. So basically, if it works at all. Because so far it didn't. Now it's triggered. Okay, now it's triggered. Now it's open. So I think we can move it up like 2-3 millimeters over the nozzle. It needs to be quite close to the nozzle, seemingly. Like it doesn't trigger a lot earlier. Let's see. So when now it's open. Now it's triggered. But now the nozzle is like quite close over the bed. I'm not quite sure if we can show that. You can see like it didn't touch yet, but it's quite close to touch. So the little bit like the trade-off you need to make here is you want to have the probe high enough up that it doesn't interfere with the print, but also you don't want to hit the nozzle. The badge shouldn't hit the nozzle, of course. Okay. Then now we can configure a bed mesh, maybe. Also, we leave most of it at the default. Mesh. I think we need to configure mesh min and mesh max. Probe count. And the rest we can pretty much leave at default. So mesh min, the probe is in the front. So I would say we do, but it says relative to the probe, right? Relative to the probe's location. So we can also check if it's correct. So mesh min would be 10, 10. And then this, we need to like, because it's 2 centimeter front, we have to do 160. And this can be 170. But let's first, I mean, first let's do G28 to home everything. Okay. And then we can do probe core, or like, let's first put this to the center. Now this will just sample the probe a couple of times. Very slow. Maybe we should have moved the bed up a little bit. Oh my god, I missed all the messages. Height 11, welcome to the stream. Something wrong, it isn't printing. Well, something wrong is it's not ready to print yet. We need to still configure quite a bit. My print parts have been lying in the boxes since last year because I haven't had time to work on my printer for the past few months. Oh, now I have to pay attention. Yeah, it stops. Perfect. Um, could they get damaged from being stored for so long? Well, if you store them in like a dry place, no. If you have them in your garden sheds, not the best place. Just store them where you have your printer stored. But besides that, the parts will not be any different if they're like assembled in the printer. Unless I'm a mode, yeah. Everything China has humid, then it must start uh, forming and the plastic film could degrade. Yeah, I mean, as long as it's dry, without sealed packages and stored in cupboards inside the original shipping box. Yeah, then it's fine. On like that sounds basically how your printer would also be stored, right? Okay, so this works, and I'm not quite sure. Seems to be okay-ish. I would say like it's 0.05. Yeah, I guess it's okay. It's not super precise, but that's good enough. Okay, then now we can do fun stuff. We can do the bed tilt. So basically, we don't have a Z end stop on this machine, right? So what we need to do first is we move the bed down and we home it by just running it against the physical end stops here, basically. Then we move it back up and we use the probe to do like a bed tilt correction, which basically means in the end the bed will be perfectly parallel to the x-axis. So if you look at the Warren 2.4 something, right, we have the quad gantry level because we can move each corner of the bed individually. For this machine, we only have two motors. And we can only have two motors. That's also something important, right? Because we have the canvas toolhead board. The canvas toolhead board drives the extruder motor. That means on our main board, which has four stepper drivers, we can use X, Y, and then we have Z1, Z2. So only because we have the canvas toolhead board can we drive the two Z motors independently. This machine is usually or supposed to be used with the Prusa mini mainboard, which has also four stepper drivers, right? They use X, Y, Z, and then they use the extruder. But now because we use Clipper instead of like Marlin, we have the canvas tool board, so we have one extra stepper driver, and we can control these motors individually. So we can just have a bit more of a nicer setup there, basically, because we have a perfectly parallel bed. Like it's not like parallel per se to the y-axis, so it could still be off in this direction, but at least like in this orientation, it will be perfectly parallel to z, to x. This is bad tilt. Better to complex. Z tilt. Yes, this is what I wanted. So we configure Z tilt. Let's put it under the bed mesh. Um, so we need to provide a list of XY positions. So we do want to have it basically above the steppers here. So I don't think it's perfect 90, to be honest. Let me see. We have something that we can use to measure stuff like this. So if I move this to the side, I can determine that the Z lead screw here is at 99. So we can use, let's not do it directly on the edge of the bed, but we do 10, 99, and we do 170, 99. So these are the Z positions we want to test. And what I wanted to have here is actually points. Z positions will be ever so slightly different. So this is literally a position where Z is driven. So from this location, the Y is the same. We are 16, 15 millimeters out. Does it make sense? That's a bit more. Yeah, it's like 20 millimeters. So this one would be minus 10. No, we at the moment we are at 0. So this would be minus 20, and I just mirror this over. So the max we have is 180, I think, pretty much spot on. 186. So then this would be 206. And then we can do 75 here. Speed we can leave in. Horizontal move Z. We can horizontal move we don't need because we don't have a probe that has something like deployed. Retries we don't know. Needs, yeah. So let's try this. So what we can do now basically is we do home. Oh, I didn't switch to the window. I'm sorry. Probe or nozzle? That's a good question, Steve. I did do now nozzle. I think describing the location of each bed pivot point. The pivot point is the point where the bed attaches to the. It describes using nozzle coordinates. Yeah, so we're correct. And the points, coordinates of the nozzle. Yeah, so this is all nozzle world. Okay, I'll quickly move up Z that we don't have to like wait so long with the slow Z move. And what we should now see is basically that the tool that goes here probes, and then the bed most likely will like move a tiny bit. Oh, horizontal moves that. Cannot be, okay. Let's just leave the 5 default. We also didn't adjust the Z offset yet. That's also still to come. Okay, then we move that back to 30. Oi, oi, oi. That was not good. Nothing happened. Let's first adjust that. Oh, are we stuck in a shutdown again? I had it before. I had this before with Clipper, that like it's stuck in the firmware. Here we go. Okay. Let's first do the Z. Because now I tried to move to 5, but 5 seemingly was under the bed. I always forget the magic commands. Um, I don't think probe set trigger. But we don't want to use the probe. What's the Z and subcalibrate? That's the magic command I'm looking for. So let's move that to 30, 90, 90. And then we do Z and subcalibrate. And now basically, do we have a piece of paper for our magic paper test? Don't think. I do have a piece of paper. So I'm just moving the nozzle now down. First with these lower buttons, because like these are like very slow. And now I'm basically very close, but not there. But now I can use these. Now it's already pinched. So these buttons, the plus and minus, they get progressively smaller in how much they move. Yeah, something like this is okay for now. Accept. And now we should be able to move to 0, and 0 should be on top of the bed and not. See if I have to pay attention, yes. Nobody saved me from this. Yep. Okay, let's try this again. But first we check. Okay, so I'm just moving now manually to 0. Look. And yeah, now it's spot on. So now basically now we're touching the bed, so that's perfect. So now we can try the Z tilt again. Yeah, so now it props one side. And now basically it did the adjustment, so it moved one stepper up and one stepper down. Not a lot, which is good. That means our frame is quite square to the x-axis, which is excellent. I mean, for me, this bed doesn't look... oh, it was on the... There's this pin here, and like the bed sheet was on top there. Let's quickly do this again. Okay, that's quite good. So yeah, so we have the bed calibrated. So what I will do now is let's make a custom homing macro. Um, you know what? Let me quickly turn on the V0 because I think this one has pretty much what we need. Your corners will be out till you manually trim the bed. The question is, can I trim the bed? Because this is completely like rigid. I don't think this has any way for me to manually adjust that. I think this is just fixed. What did you configure for tolerance? You mean for the tilt? I left a standard value. I didn't configure anything there. Okay, let me quickly steal the macro from here. So this does a couple of things. So it reduces the run current. But why is this two different macros? Never mind. So this will basically check what it needs to home. It will home Y, then it will move in, then it will move home X. This is center bad supposed to be, so let's just adjust this. Then we do the G28. There's some stow brush command here. We don't need that. Then we go to Z10, I guess. And then we do Z tilt, which basically means like we do the full homing, but then we do the Z tilt already. Let's see. Okay, let me also check like the first move down the bed was quite aggressive. Because we do move the bed a little bit down. Ooh, wow. That was fast. How about we try this at half speed? Um, but where did that initial, here. And I think this we can make a little bit faster. And then this will be center bed. Let's try again. Oh, but also like, yeah, the command is Z tilt adjust, not Z tilt. Let's also quickly do that. That's why I didn't do it just now. It still hits it quite hard. I think I will reduce a little bit the current here. Because the home current is 0.7, that is as much as we have on normal. So I will just set it to 0.4 amps. So basically we reduce the current when we're homing, so the stepper has less power. But also what I want to do, this horizontal move, let's speed it up a little bit. This can be at 100. Also for the, oh, I did the bad mesh. So do that tilt. Let's try again. And I think we have quite a good setup. Then let's quickly do like a bad mesh, see how bad the bad is. So now it was not sensitive enough anymore. So we have to adjust this sensitivity value a bit. Which is the strength here. So that's something we have to quickly try out. So I would just put this to 120 for X. Let's try X first. Oops. G28X. So we only home X. Isn't more sensitive. Let's try 90. We had 105 initially. Mr. Design, Z tilt adjust. Yes. I also noticed that. Let's see. Does not like that. I recall, let's just put it to 250. That's the most sensitive, almost. I think 255 is the most sensitive. Just so that I want to see basically immediately it should stop moving. Okay. Let me try like a very low value. I think 250 is the most sensitive. Okay, now it's just broken. Okay, let me restore the 105. And in macros, let's quickly check what we do here. Because we only reduce the current. I mean, let's quickly see if we don't do that. Not quite sure why it's now not homing anymore correctly. Okay, now it does it. So it must have something to do with setting this value here, home current. Usually if you reduce it, it's better, right? Let's try 0.2. Like it just should give less force to the stepper, so I'm not quite sure why it messes this up now so much. Okay, we leave it at 0.7. If that works, it works. That's something we can figure out at another time. The problem is now it hit so hard that it skipped forward, so now our Y position is off. It's odd. Let me quickly check the values here. Most sensitive value, yeah. Okay, let's not mess with these currents at all. Because it worked fine before messing with these, so let's just try it completely without. Yeah, like this it works. So okay, that means we are homed. Let's quickly wait, and then let's create a map. And then I think we can start. I don't think we forgot anything. That should be pretty much it. We still have to adjust the offset of the probe, but it should give us like the rough idea if the bed is any good. And there's a problem here on the back. We have to move it a little bit forward. There's this cover from the cable here, and this touches the nozzle. That's why this one is horribly off. um, let's quickly adjust that. So the bed mesh, this needs to be one. It's just there, 155. So a bit forward. Yeah, there's nothing configured. Retry tolerance is 0 by default. I mean, these like small configuration details like we can do later, I think. Generally, like it seems to work. Um, No, still, this one is like way off. Like way, way, way off. -1. The thing is, like, I remember now we had issues here with the mounting of the bat. And the corners are not supported, which I think is not the best setup. I think here it's just like the weight of that connector most likely pulls it down a bit. Let's see. So this is something we have to work on. The bat mount. Noted. But for now, this should be fine. We will be able to to print something in center of this monstrosity. Um, oh no, it still touches. It's still, that's why the corners are off. It still touches. It still touches the connector. Let's just move another 5 mm. Oh, I'm so stupid. What are we here? 60. It's not 170. This should be 165. That's why it touches. I didn't change it. Let's try again. Now it hits again so hard that it moved the Y forward. So that's also something we still have to figure out. Retries 5 and tolerance 0.075. I can copy these values. While this is doing that, let me just copy these values. I would say it's a bit better, but still like horribly off. So how the bat is mounted is definitely something we have to adjust. Okay. It's called retry tolerance, right? Retry tolerance. Let's try again. And generally, let me just raise the sensitivity here like a itsy bitsy up. Did you adjust the SG4 thing? No, I did not do that. That's true. Because the TMC auto tune does have that. Again, let me quickly like take a peek here at Clyde. I don't have TMC here. No, I don't have the TNC auto-tune here. Interesting. Um, oh yeah, and interpolate true, we also still have to set. Uh, yeah, exactly. So that's why it doesn't matter what value we set there. Um, so this is 110. So just explanation, I have this TNC Auto-Tune Clipper plugin. It reduces the vibrations on these Creality motors like a lot. But then basically it overrides this value here, so you have to manually set it in their configuration. No cheating from client? No. All cheating. I need my cheating. Let's quickly see if that solves our problem here. Hey, don't ask me what that was. Oh, something is really wrong. What is it doing? Why is now X moving forward? Something is really wrong now, but what did I do? I added the interpolate true here, and I set the SG4 strength. Let me remove the interpolate. Steve, what do you want to set to 0? If I set this to 0, it will not have any end stop, right? 255 is the most sensitive. What is it doing now? Let me restore what I had before. What the hell? What did I do? So this is fine. Well, let's say set kinematic position x 90, y 90, z 20. Okay, so this way I can move x correctly. Okay, so now it seems to work. Like I can work. I can correctly move it in plus y, minus y, plus x. Okay. So now the question, Why is homing now so screwed up? Now it's fine. What the hell? Let's try this again. Yeah, now it works. What the hell was that? I have no clue what this was. Now it also takes the correct value. Because now it's like very soft. Holy shit, I have no clue what that was. Now it takes it 5 retries. There you go. Okay. Weird, but I accept that. Let me quickly do the Z probe adjust. Calibrate? I never get my probe calibrate. My bad. So let's move that down. Same as we did before, basically. Oh, oh wow. We actually had it like pretty much spot on. Very nice. 0.3 millimeters off. That's quite a good initial guess. Now the one thing I want to do is like the probe offset is 1 millimeter. So I want to change for the Z tilt the Z height. I want to move it down a bit. Z tilt speed horizontal move Z. So I want to move that down a bit. Let's do 2. And the same for the bed mesh. I think it's the same value. Fingers crossed. Yeah. Now bed mesh. Yes. I totally forgot about the bed mesh already, Steve. It's funny, like every time it starts moving, like the y-axis like moves a bit. So this will be like horrible print. Now it doesn't touch. I think. Just barely. I want to move it like another 5 millimeter forward. I don't trust it. But now I think it's more even left, right. So I think it doesn't touch anymore. And bad mesh. Let's do 160, 160. That's 10. Perfect. Okay, cool. Let's get started with extruder calibration. Let's melt some plastic. Hi, the best Glaser. Welcome to the stream. Yeah. So it still like has almost a millimeter in difference from front to back, but the left to right is a lot better now. So I think it's just like hanging a little bit, but we don't have springs to adjust that. You will need access twist compensation after you fix your y-axis. Yes. But right now it's there's nothing you can fix there. There's one problem though, or like problems are hard. I think the inbuilt spool holder we have here still does not work because the rods here stand out a tiny bit. Let me quickly see if this clears. Oh, yeah, it works. So we can use the inbuilt spool holder. Isn't that nice? Yeah, but that's the risk. Like, so there are like these two rods standing out here. And it's very easy for the spool to catch on those. So I don't think it's a good idea to use the spool holder for now. It's very easy for the spool to catch on that. Although later on, like we will not print this low for now. So I think it will not be a problem, but for larger prints, this will be something we need to fix. Okay. Let's heat the hot end. Quickly cut the end here. Ooh, 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 ooh. I see molten plastic. So I'm using quite a high temperature now because we want to calibrate the extruder. And we don't really care about but why does it not grip? Why does the extruder not grip this? I have to tighten this more. Now it's pretty much. Now it grips it. So I really have to like tighten this. Let me quickly see if we can extrude. Doesn't seem like it. To manually push it through, it doesn't. But the extruder doesn't move. The motor doesn't move. So you see what we configured there. Extruder. Seems to be correct. We use the EVB36 configuration. Wiggle the latch, they sometimes catch. Yeah. I mean, now the extruder grips it, right? Like I have to use the latch to pull it out. So this definitely grips it now. And I can also push it through manually to melt it. But like if I move the extruder, nothing is moved. Which is a bit odd. Settings seem okay. Oh, it does it. We just have to calibrate the extruder maybe, right? Because the rotation distance most likely is completely off. It's a very weird way. Rotation distance, yes. So these we need. Uh, let's see. But it's quite constant, the temperature. You don't see it, but it's quite okay. So I don't think we have to do a pit auto tune immediately. Yeah, now it does the wrong direction, so the direction pin we have to invert. Wait again here. No, it's definitely pulling filament in, so that's good. Deer pin we have to invert. Yes. Now we are in business. Okay. Where are my markers? So this is kind of the same spiel as always. So we measure out 12 millimeters or 120 millimeters, aka 12 centimeters. And then let me quickly peek at Alice's print tuning guide, which has the tuning, extruder calibration. I hope the extrude only distance is okay. We will see in a second. And this will extrude very slowly. Yeah, exactly. Extrude only move, you have to adjust. So basically, Clipper complains that we are like not moving the print head, but we're extruding too much. And it's a protection feature. How is this called? $150, whatever. Did you use max extrude only? No, I did not. I was hoping for the best. Here we go. Yeah, now it's agonizingly slowly pulling in the filament. You just do it very slowly, that you don't want to measure anything else except for the extruder. So I use relatively hot temperature here with 240 degrees for PLA. So it's nice and fluid. And then you also drive very slowly that you ensure that there's no performance impact on the extruder. Because you only want to measure the gears basically. It's still doing it. Still pulling it in. Yeah, it's off by like 2 millimeters. So we have to quickly calculate that according to the formula here. Let me quickly grab the old rotation distance that we had. And the calculation is previous rotation distance times actual extrude distance, which was 102, divided by what we commanded 100. And that gives us 47297. 729. Let's do this one more time, and now it should be pretty much done. You'll need to create an Orca profile for the printer, or is it already available? I don't think there's a printer profile for this. So we will need to create one. But we can keep it relatively straightforward for now. Okay, let's try again. The exact same command. I just quickly have to measure. And then now I expect that we're like pretty much where we need to be. I wonder if we can just use a Prusa Mini profile, to be honest. Because it's a Prusa Mini. As far as Orca is concerned, there should be no difference. Right? Because like what is Orca is like it's a Prusa Mini running Clipper, basically. That's all Orca needs to know. But yeah, that's the next step. CoreXY. But does Orca care about CoreXY? Because Orca doesn't know the motion system of the printer, right? Orca needs the dimension of the print, sorry, of the print pad, and that's pretty much it. And the general capabilities of like acceleration stuff, right? See, is this that? Almost. Yeah, I would call that okay. I will recalibrate it later with a bit more precision. I think now we're a little bit over, but it's good enough. So let me connect that and let me put in this clip. Amazing. Let me find the clip on the floor. Oh, I see. 1 second. Here we go. Let's do the following. Pit auto. Oh, pit calibrate. Pit calibrate. Heater is extruder and target, let's say 230. Then while we are messing with Orca, this thing can like do its heat cycle calibration. Yeah, the problem here with this like mount is like the acrylic glass here pushes the spool like a tiny bit forward. And then it presses it out. Yeah, I'm not sure if we will use that spool hole for now. I think we need to like fix it a little bit. Okay. Here we go. So create a printer, I guess. Let's read just like I'm pretty sure this will work out. Yeah, push a select model is not fun. Wait. I'm not doing that very often, to be honest. Yeah, it must be. Oh, say, this is what I wanted. Yeah, but indeed, they don't have presets for Prusa Mini. Interesting. Still using autocomplete. No, I don't. I didn't have all the updates installed, I think. Okay, well, it doesn't have any profile, so we need to create one. So we have nozzle. The printed space is 160 by 160, right? And origin is 00. SCL and bed, whatever. Max print height is also 160 as far as we are concerned. Printer preset. That's a bit of a shame because, like, I mean, I can't select. Ah, that fuck. Now it comes up with that. Uh, Filament presets, we are not. At least one filament preset. Uh, Foam, Futura, Easy Fill. Let's say standard and speed. Printer settings. Okay. So G-code flavor is Clipper. That's the important change. And it's a hardened steel nozzle. Let me quickly save that. I will copy over the start G-code. That's the other important thing, right? That's okay, whatever. Motion ability. Let's leave it like this for now, doesn't matter. Extruder. Retraction 2.5 is quite extreme because we have like direct drive. So let's just do 0.6. What else should we check? Should be fine. I think these are kind of the important tidbits we need. Let's do a Voron cube. And what I always like to do is like the hollow ones for testing. So strength is 0 top shell layers and sparse infill is 0. Print end macro. Print start macro I didn't add yet, and print end also not. I was just thinking about that. I will copy it over from Clyde. That's not for you. Hello, good sir. Oh, Clyde is off. Oh, no, now you have to show your... He's in Christmas outfit with his Christmas bow tie. I couldn't resist, but he's not bothered by it at all. Don't mute the microphone again. Let's give this a second. More cheating, yes. And also Pretty Boy, I can confirm. Dum -dum. Homing. Alright, we had print start and print end. And I will put the config online on GitHub later. And this is all a bit more fleshed out. Let's quickly go through that this all makes sense. Print end, I think we can leave pretty much in place. We don't have this ch home is a conditional home. So basically when it's already homed, it doesn't home again. So I will add that here too. Bad mesh calibrate adaptive 1. We need to quickly set it up because I want to have that. We don't have a beeper, so that's sad. We can leave it in. We don't have a filter, so we can comment this out. And then nozzle purge and light printing, we don't have nozzle perch. We have to copy over. Center front. Just the perch line for the beginning of the print. It might say that we have to increase the volume. The extruder is always complaining. I'm quite aggressive with my perch in the beginning. Let's copy these min-max here. Okay. Then adaptive meshing should work if in the main sail Moonraker conf we have the object processing. Let me quickly also check this. Moonraker conf. Drup, drup, drup. This one I want to quickly copy that I have remote access working. And update manager, file manager, enable object processing. This one is the one I want. And then Moonraker we also restart. See, Loki's pretty chill now. Yeah, he has like a very chill face at the moment. Like it's a little bit up and down. Like I feel like some weeks he's growing, then he's like very chill. So this is like a growing week, and then the weeks he's not growing so much, he's like hyperactive, and there's no way you can power him out. Like he was like in his cat bowl the entire time now. Now he just came down. Now he ate. Now he's like exploring a little bit, and then like he will sleep again. um. Yeah, but technically, I think we're ready to print, right? Let's just see what happens. I have with this spool holder here, I have to pay a little bit of attention with these like things that this doesn't catch. But in Orca, let me quickly configure the. It's not Pusha link, of course. This is Octo Clipper. Satsuma.local. And then we can slice that. Looks good. Let's not print it in ABS. Fire. The bed will not be accurate. No, it doesn't, because we didn't do the pit calibrate, but the pit calibrate for bats takes so long. It's good enough. Okay, the bat is seating. Also, arguably, maybe it's good to have the Z tilt again after the bat is heated, to be honest. I think we should move it out of the print start. We should move it out of the homing into the print start. I can do that. So the Z tilt adjust, I move out of the homing and I will move it into the print start. Before we do the bad mesh calibrate, we do Z tilt adjust. For now, it doesn't matter, but for the future. Did you copy the pit config for the hot end? We did pit calibrate while we were in Orca. I did pit calibrate on that. So for the hot end it's fine. I did save config, so it should be applied. But also before we did the pit calibrate, it was kind of okay. Oh, the adaptive meshing is not working yet, so something else is still missing for that. Just did it from the top of my head. The bed is heavily overshooting though. Like we know it's 64 degrees of 60. Let me quickly Google Clipper adaptive bed mesh. Adaptive meshes, what do I have to do here? Let's see, maybe also something in the start macro is not correct. Can you? It pooped plastic? Holy shit, like this vibration here on Y is real. Let's see. It looks semi-okay so far. Move a little bit. It definitely has problems with the circle in the middle. Wonder why. It literally just moved the bed. I wonder why it has problems with the circle in the middle. They can't print the circle. Hmm. Weird. That does not look good. You can see the whole printer. Yeah, I see that too. So Y is horrible, X is quite okay. Uh, I think cooling is not a big concern right now. We did kind of like knock off half the fan duct here, right? So all the air is here. So cooling is definitely not perfect. And it's also coming off the bat. The heat bed has like very big temperature. Yeah, exactly. Let's see. So, I mean, it's something. Uh, how many? I didn't pay attention. The print technically can go up to 16 millimeter cubed. But I will also try not printing like slow because it was quite fast. I mean, it's printing. We did have layer shift where like it got caught on the bits of filament in the center. And you definitely see the rocking, but it actually, like you see here, this translates into the print, but it's not as bad as I thought it would be. Let's do the following. Let's print this again. Also, like the park position is quite stupid with this block here. So let's just print this again, and I'll reduce it. Yeah. Let's try this again. So with homing, we still have a bit of issue. It was like now it gets caught on this. But here's the cover of this connector, and the nozzle gets caught on this. The fans are running. We checked that. Both are working. Okay, I will print this again. And I will set the speed factor to 50%. It's like it's weird. Like the circle it literally couldn't print the first layer, then kind of got okay-ish, but I wonder why. It looks quite under extruded, to be honest. But could also be because this was printing like mid-air. Let's see, second attempt. Adaptive margin. Mr. Design, I just see your message. Yeah, I think there's a default value, so it should be fine, right? Yeah, I have no clue what it's doing there. It also looks funny what it prints. And it's definitely too close to the bat, so I will move it a bit up. But you see, like it crosses like really weird with this circle. I have no clue why this circle is so weird. Yeah, you want to have this? Oh. Because the rest of the print's okay. It's really just it's all in the circle. Like I feel like it doesn't do the circle. I will observe it again. Like I don't think that's the circle. No, it doesn't do the circle. Like it crosses through the middle of the circle. Oh, I think it uses arc moves. And it uses arc moves. How can I? I didn't add exclude object either. That's true. Okay, let's quickly cancel this. I think I know what's going on. I emergency stop it because it will run again in this thing here. I think what's going on is that the printer profile in Orca uses arc moves, G2, G3 moves, but we don't support that. Clipper arc moves. Just G-code arcs I have to add to the printer context. Okay. I think then, so basically, normally G-code only uses linear moves, like just like lines. But you can use arc moves, so circles or arcs. And that's way more efficient because like to represent a circle, you have to do like a lot of like linear moves. So it just inflates the files and like makes also like a little bit stuttery prints. I think Orca at the moment, because we said it's a Prusa Mini, they most likely support arc moves. Extrude object also goes in the printer config. And then we want to set for the bad mesh, depth margin is 5. Let's try again. And you can also quickly check here in the preview. Let's see. Wasn't there a display that showed the commands? I click download this file. Can I download this, please? Doesn't download. Okay. Well, let's see if it does now. Oh, but the adaptive margin now works. So Mr. Desai exclude object was missing. I'll also move it a little bit up with that offset. G code view. Yes. Does it show the commands though? Because in I just missed it here in Orca right now. Like usually there was like this small window that showed you the commands. But I think this looks very archy. Let's see what it does. Ah, do I see a circle here? So it uses arc moves, and we didn't have arc moves configured. So instead of like doing the arc, it just skipped the move. It just skipped it. And you can't really make a circle without the arc moves then. Here we go. I feel like we had this issue before. I think for Improvement for the first sprint, we had the exact same issue. It's so way too low. Even with this very shaky y-axis, it moves quite well, so that's good. It also uses Z-hop. I see Z-hop here. Z-hop on top and bottom. I don't want Z-hop, please. Hey there, Ravenkeeper. Welcome to the third print. I tossed all the poor man Warren cubes, Mr. Desai. I don't think I kept any. I would need to check, but I don't think I have any. So again, some watching on the phone earlier, seems setup went fine. Yeah, I mean overall, like quite smooth. Couple of hiccups as always, but it prints. Does it print pretty? Definitely not. But that's something we are about to change. And I think this print surface this print is horrible. Like nothing adheres to this. This is already curls up again like crazy. Let's see if it survives. Uh, Try it in out shaper, but boy, it's definitely an issue here. Yeah, definitely. I don't even. I'm not even attempting a shaper. Was the tool very loose, or did it just look like when you adjusted the float? No, the tool head, the y-axis is completely crooked, or like not crooked, but like it's the y-axis is basically shifting forward and backward because these bearings in y are too loose. I swapped in new bearings on X. X is fixed, but on Y I didn't do that yet. So it's incredibly like shaky. It's not a pretty print. Like it's printing. This is the goal right now. And the fact that it's not printing nice, we can fix that. But now it's just like nice to see that, like like it's doing something. Without distracting to the print, he has a new favorite spot, which is there. I mean, it really messes with that. And I see it coming that he jumps down on the table and like lands on something that he shouldn't land on. The toolhead itself, I think, is quite nice. I also like that it's like balanced in the center, so it has some components on the back and some components on the front. So it's like quite balanced, which I think is nice. We just need to. I did break the air vent here on this side, so that's why that's open there. Um, and I think the extruder has also some calibration needed. How much plastic do we push at the moment? So we're pushing like 5, 6 cubic millimeter per second. Yeah, I think the main issue is just like you see these rings, and I think this comes from the X from the Y wobble. Most likely, once this is solved, it looks already a lot better. But I think then also we need a lot of work on the extruder. Like I'm not quite sure. It's very hard. Like the layers are extremely inconsistent now because of the tool head not being like properly fixed. Um, but I think like the first thing to do is really like fix Y, and then like the rest most likely will be the other issues will be way more obvious to spot because right now it's just like all over the place. I see it coming off the bat and like very soon. I think that is barely holding on at this point because you see like on the complete front like here it's like completely like loose. There's definitely some extrusion issue. Um, you see like there's some under extrusion here. I also feel like it's just a bit all over the place. I feel like the extruder is still not really gripping properly the filament. And we're not really pushing hard at the moment. It doesn't print crooked, so I think this print is clearly superior to the 2.4, I would say. At least it's vertical. And that was a shit show. Like the amount of time it took me, or like also like I think this is I figured out at the end by finding the correct post in the Clipper forum. But it was basically I installed the initial firmware I had installed on the 2.4 on the first print. I had a bug, and that bug basically caused it that the cube wasn't like vertical, but it was like tilted like this. It's like I mean you don't expect a Clipper bug doing that, so we checked all the hardware and like why does it like not move perfectly upwards. It's like horrible. That's definitely a win. Like this is roughly what I expected quality wise, to be honest. So from here on, I think the next step really is like fixing the y-axis, and then like you will have like way more consistent layers, and from there on you can sort out the extrusion topic. It was only bug with the MAP. I was on this very specific board. So it's basically one board and this one Clipper version. Yeah, here we go. Okay. I mean, it's not perfect, not even by a long shot, but it is printing. Focus? No focus? So it's printing. You definitely on X it looks a little bit better. On Y it's horrible. Like why do you not focus? Can you focus? Yes. Just do. Oh, here we go. So on Y, you see like you have these like massive rings here, and that's just from the tool head shifting. Yeah, this is why. On X, it's a bit better, but here we see definitely like extrusion issues. But also X is not very consistent in the layers just because the tool head basically moves up and down. So the nozzle distance to the bed constantly changes a bit. So yeah, but there's definitely extrusion issues here. Although this could also be, yeah, a combination of the two. But like here you can see like these massive rings, and it's just like from the tool head moving up and down. So the Y bearings is the primary issue. Um, it's still too close to the bed, I would say. No, not even that much. Um, but this bed is, I also don't like it, and I didn't clean it, so it's also dirty as hell. So there are some culprits. I do have though. Maybe now is a nice point to do that. I did order that together with the 2.4. A nice OSEC sheet. And I think this one will be a lot nicer and easier to grab the filament on. Let's not probe calibrate in the corner here. But I would say that's it for next time. So I basically next week, Wednesday, I will travel to my family for Christmas. And I'll be back basically end of December. So that will be today the last stream of the year. And then we start again in January. Next steps clearly is fixing this again, like just to show on camera, like this is where these like rings come from. This is the problem. I wonder what the cube looked like. Didn't replace the X-Bearing. I think the cube will look even more horrible. So the X-Bearings, again, like for everyone kind of tuning in midstream, I explained it right in the beginning. So I think the bearings I have here are just not good. So these are the bearings I pulled out of X, and they have just a lot of play. Like you see it here on Y. And first I thought like these are just not good enough. Like there is a longer version basically that's like, you know, like this length, like double the length. And then like they have more contact and like have less wiggle. So first I thought it's that, but then on the Prusa Mini, they have the exact same setup for the tool head mount with these two bearings like this on top of each other stacked on two rods. So it must work, right? If Prusa sells it as a Prusa Mini, it must work. I then compared with somebody on Discord. My rods are exactly the same, 8.1 to 8.2. So it must be the bearings. And I think the bearings I have too much tolerance. The funny thing is like I ordered like a lot of different bearings like this here for the poor man works. Why? Because we want to try out different things. And all of them are so sloppy. We also tried on poor man corks white these IGOS bushings here. So the other ones have balls, these don't. And these are now here on X. And these are like a lot tighter. I think these are the correct dimension. The only downside of these is they have a little bit more friction. They are more silent, but they have a bit more friction. So I'm not quite sure if I want to have them really on the printer because, yeah, it might limit a little bit the performance. So for now, I only swap them in X because X you can swap the bearings relatively easy. Y is a bit more painful, so I didn't do that. But I ordered new ball bearings that are supposed to be better or like properly dimensioned for printers. So I want to try them out first, and then we can decide whether we go with the bushings or the new ball bearings. But yeah, this is like the main problem why everything looks pretty shitty. And I think also the extruder, like I still feel like the filament is No, no, now I'm putting the bone. I still feel like the filament is slipping. So that's another topic that we need to check. Um, because like here on the screw, like I can't make it tighter. So something might be a little bit off with this extruder, but it's a pre-assembled extruder, so it's not my fault. But yeah, this is, you can see like in act, like if I twist it like this, it's basically not moving, and this is like this. So let's see. I think Prusa will use quality bearings, not cheap from AliExpress. Yeah, what's the thing? Like I use the Fushi bearings. They're usually very good. I think it's just like the wrong tolerance. I feel like on rod bearings we need to preload them in CAD. I did it on the CNC, where on the rods 0.2 offset, causing more or less wobbly setup. Yeah, that's also a thing. Like, I mean, in the poor man, like I put an insane amount of pressure on these bearings. Not sure if you remember. I saw the same issue. I don't think the metal ones you can really push together. These the bushings, you can put so much pressure on them that they bind. That's possible, but I think for the yeah, but it's the thing. Like these are not cheap Ali bearings. Like they are from AliExpress, but these are the Fushi bearings. Like yeah, I don't know. I normally like the Fushi bearings are really good, so I don't know what happened there. You have the screw too tight now and squashing filament. Maybe, but without the screw being tight, I was able to pull the filament. Yeah. Ah, no, now it's okay. Yeah, the screw was too tight now. But why did it not grab? I think, Steve, what you said that the arm was caught somewhere, I think that's correct. Because like now it's properly grabbing the filament. So I think you were correct there. Like because now like it's like I have resistance, I can pull it through the extruder. I dropped the thing again. Well, let's use it as a cutoff point for the stream. I'm super happy. Like it's printing. We did the full like not calibration, the full configuration. We have sensible macros in place, like it does the Z tilt adjust, which actually also without the Z tilt adjust, like it's quite good already. So working points would be, I think from software point of view, like we're kind of okay for now. But we need to improve. Obviously, like we need to do full calibration. But at least input shaper and extrusion multiplier, you can't really calibrate that if your print quality is this shit. So at this point, I don't think we will do that. I think the first point really is like hardware-wise fixing this to have this wobble gone. I think that's the most important part. Then also hardware-wise is very important. I should not forget that. Is I have to shorten these lead screws left and right for that. These two, I have to shorten by quite a bit, like by like 2 centimeters or something. And then we have to reprint or like replace this part here where the nozzle is, the air duct is broken off, which might be quite a pain to replace, to be honest, because this is the main part that holds everything together, I think. So that's quite a painful part to replace. So that will not be fun. So I think next stream we will replace the bearings here in Y, that we get this wobble out. And we have to rebuild the tool. Not rebuild, but like we have to replace the parts. We have to take quite a bit of stuff apart. Yeah, that's pretty much it. I would. It's a good looking printer though, yeah, but not a cake. Maybe you can use it to print cakes with chocolate. But yeah, I guess it's at this time of the year, so already we won't see each other or like watch each other again until next year. Enjoy your holidays, happy Christmas, and happy New Year. All the best for you, and see you next year. Bye.